Hello and welcome to Math with Mrs. Becker. Today in Algebra 2, we are going to look at the first half of section 5.7, where we will be graphing quadratic inequalities. So just as a quick reminder, if something is quadratic, that means that your variable has to have a power of 2. The shape of the graph will always be a U-shaped graph that is called a parabola. We are going ahead and changing our equal sign into inequalities. So you're looking at things like less than or equal to, greater than or equal to. We can go ahead and graph these. The cool thing is, remember when we graphed linear equations and then we turned them into linear inequalities? When you had a greater than or a less than symbol, you had a dotted line. Same thing here. If you have a greater than or a less than symbol, it's going to be a dotted parabola. Where if you have a greater than or equal to, less than or equal to symbol, that would have been a solid line. So in this case, it would be a solid parabola. And just like before, when we were graphing inequalities, remember you always had to try a test point, okay? Any point that was not on the line. Now here, when you try a test point, it has to be any point not on the parabola. And again, you shade what is true. So when you shade here, you will either shade inside of the parabola or outside of the parabola. So here will be our steps. You graph the parabola. Solid if it's less than or equal to, greater than or equal to. Dashed or dotted parabola, less than or greater than. Shade inside of the parabola or outside of the parabola. So you will either have a true or false portion, and depending on how that is, you will shade inside or outside. Okay, let's go ahead and let's do this. So if I want to graph y is greater than or equal to x squared minus 7x plus 10, if I want to find the vertex, x equals the opposite of b over 2 times a. That's how I find the x value. So when I go ahead and do this, it's going to be the opposite of b, so positive 7 over 2 times a. A is a 1, 2 times 1 is 2. 7 divided by 2 is 3.5. Now to find the y value, I have to fill that in to the original. So if I have 3.5 to the power of 2 minus 7 times 3.5 plus 10, my y value is going to be a negative 2.25. So that's where the center point is. I go to the right 3.5 and I go down 2.25. Now notice the labels for your coordinate plane were going by 2's. Your axis of symmetry, it's going to cut the x-axis, so it's always x equals whatever the x value was in the vertex. So that is going to be the mirror image line where you will be able to reflect that parabola from one side to the other. Your y-intercept occurs where x is 0. So if I fill in a 0 here, this would cancel, I would have a 10. So 0, 10. Now remember, you can reflect this over. So this is 3.5 units away. So if I go 3.5 units the other direction, I would have to have a point at the same level because it's a mirror image. To find the x-intercepts, you set this equal to 0. So x squared minus 7x plus 10. It's a power of 2. We have to find the zeros using one of the techniques we've covered in this chapter. So you may factor. You might do the quadratic formula. You could complete the square. Now this one, I notice I can go ahead and factor. Two numbers that multiply to 10, same two numbers add to negative 7. Well, that's negative 5 and negative 2. Negative 5 times negative 2 is 10. Negative 5 minus 2 is a negative 7. So factored, it's x minus 7, x minus 2. But you're factoring to find your x-intercepts, which are your zeros. So now you take each factor separately and you set it equal to 0. So here I would add 5, so x equals 5. Here I would add 2, so x equals 2. So if I go to the right 2, that's where the graph is going to touch the x-axis. If I go to the right 5. So now I have enough points. We need to see, is it a solid or a dotted parabola? This one would be a solid. And again, just like we had boundary lines, you need to make sure that this parabola goes all the way through your graph. Now we have 2 distinct regions, inside of the parabola and outside of the parabola. So we need to try a test point, any point that is not on the graph itself. I am going to go ahead and test 0, 0. So if I test 0, 0, you go to the original, and we need to see if it's true or false. I replace the x's with 0, and I replace the y's with 0. Y becomes a 0. My sign is greater than or equal to. If x is a 0, this would be 0. This would be 0. I would have a 10. So my statement is 0 is greater than or equal to 10. Well, 0 is not greater than or equal to 10. So outside of the parabola is false. So I shade inside of the parabola. What this tells me, any ordered pair that is within this parabola, if you put that ordered pair into the original inequality, you would have a true statement. Okay, so a lot of similarities as far as things that we have already studied in this class. We have test points, we're graphing quadratics, but the cool thing is that we're bringing it together to learn a new skill. Let's try 2 more. Okay, if this is my inequality, if I want to find the vertex, remember your vertex is an ordered pair. To find the x, it's x equals the opposite of b over 2 times a. So here, b is a -5. The opposite of a -5 would be +5 over 2 times a. A is a 2. 2 times 2 is 4. 5 divided by 4 is 1.25. So I have my x value. Now to find the y value for the vertex, what I need to do is go ahead and fill it into the original. So 2 times x, which is 1.25 quantity squared, minus 5 times x, which is 1.25, minus 2. I end up with negative 5.125. So that is going to be the center point. This time, notice everything is going by ones. So I go to the right 1 1/4, down 5 and a little bit. So it's just off the graph, but that is totally okay. Your axis of symmetry, it's the line that cuts the x-axis, so it's x equals. It's always the same x value as your vertex. So it's 1.25. So here is my dotted line. My y-intercept, that occurs when x is 0. So if I put a 0 in here, this would cancel, this would cancel. I have a -2. So if I stay at 0, my point is down 2. Now remember, I can flip this over. So this is 1 1/4 units away. So if I go over 1/4 and 1, I'd have a point about right there. And again, it's just kind of approximate. You're trying to do like a mirror image. Your x-intercepts, I go ahead and take x squared minus 5x minus 2, set it equal to 0. This time, let's find them by using the quadratic formula. A, the value in front of x squared is 2. B, the value in front of x is -5. C, the value at the end is -2. So to find the number underneath the radical, it's b squared minus 4 times a times c. So I have -5 squared minus 4 times 2 times -2. I get 41. Okay, so x equals -b. Negative of a -5 is positive, plus or minus the square root of 41 all over 2 times 2. 2 times 2 is 4. Typically, if we were just saying, hey, find the zeros using the quadratic, you would get to leave it like this. But you guys, the whole idea here is I want to know where those zeros go. So I need to calculate this. So let's go ahead, and we will end up with decimals, but that's okay. So if I go 5 plus the square root of 41, hit enter, that's the top, divided by 4. So I have 1 0 at 2.85. Now you do the same thing with a minus. So 5 minus the square root of 41, hit enter, that's the numerator, divided by 4. I have -0.35. So I go ahead and plot those points. If I go to the right 2 and almost to the 3, I'd have a point. If I go to the left about a third, I have a point. So now I do have enough points to form my U-shaped graph. Before I do that, I want to see if it's solid or dotted. This is going to be a dotted parabola. Again, think of that whole boundary line. You have to make sure you go all the way through the graph. So we have two distinct regions, inside and outside. Now we have to do a test point to see where do we shade. Do we shade inside or do we shade outside? I'm going to try 0, 0 because that is inside of the parabola. If I am testing 0, 0, remember that means my x is a 0 and y is a 0. Y is 0 less than, if I change the x's to 0, that would cancel, that would cancel. My statement says that 0 is smaller than -2. So if we're thinking of temperatures, this thing says 0 is colder than -2. That is false. 0, 0 is inside of the parabola, so inside of the parabola is false, so that means outside is true. So you would go ahead and shade all the way around the parabola. Let's do one more just for good measure to make sure we've got it, and then your assignment today is to do a worksheet where you will just practice the skill. Step 1, I want to know where the center point is, that vertex. Remember to find the x value. It's the opposite of b over 2 times a. When I am using this inequality, b, the number in front of x is -6. The opposite of a -6 is a +6. 2 times a is a -3. 2 times -3 is -6. So my x value, +6 divided by -6 is a -1. So the x value is -1. To find y, I have to go in here and fill it in for x. So -3, fill in a -1 squared minus 6, fill in a -1 minus 2, and I get 1. So my vertex, I go left 1, up 1. That is the center point of the graph. Now your axis of symmetry. It's x equals whatever the x value was from the vertex. That's where you have your dotted line. That is a mirror image of the quadratic. Your y-intercept occurs where x is 0. If I fill in a 0 for x, this would cancel, this would cancel. I have a point at -2. I can plot this over because this line is like a mirror image. Now to find my x-intercepts, you take the function and you set it equal to 0. Now you need to do things like complete the square, factor, quadratic. I'm going to go ahead and do the quadratic again because remember the quadratic is the one that works 100% of the time. So typically when I'm doing a problem, I look, and if I can factor it quickly, I'll do that. If I look at it and I'm like, oh, that looks like a big job to factor. And remember, factoring does not always work. Like if I have a number in front of my square term, I'll just jump right to the quadratic. Okay, so this is the one method that works 100% of the time. So it's kind of cool to go there. However, if you really love completing the square, you could do that every time as well. If you are a factor junkie, you can try to factor every single one and see what happens, okay? A, in this case, we're doing the quadratic. A is the number in front of x squared. It's a -3. B is a number in front of x. It's -6. C is the number at the end. It's -2. So I have b squared minus 4 times a times c. When I calculate that, -6 squared minus 4 times -3 times -2, I get 12. X equals -b. B is a -6, so negative of a negative is a positive, plus or minus the square root. The number that goes underneath the radical, we already calculated. It's a 12, all over 2 times a. A is a -3. 2 times -3 is -6. Now here's the deal. We are trying to figure this out so we can graph. So I'm not going to worry so much about simplifying this. The bigger picture is I want to get the decimals so I can plot it. So I'm going to go ahead on the calculator. Remember, this is actually 2 answers. 6 plus the square root of 12, hit enter. That's the top. Divided by -6, that's -1.57. So if I round it to the 10th, it'd be approximately -1.6. Do this again, but now it's a minus. 6 minus a square root of 12, hit enter. That's the top. Divide the top by the denominator, which is negative 6. I have negative 0.42, so approximately negative 0.4. Go ahead and graph those. So I go to the left 1.6. I go to the left almost half a unit. Now I have enough points. I have found my vertex, my axis of symmetry. I know where my y-intercept is. I reflected it over my axis of symmetry. I found my x-intercepts where the graph crosses the x-axis. Now I can connect the parabola, but first see if it's solid or dotted. This would be a dotted parabola. Now what I need to do is do a test point. This time 0, 0 is pretty darn close to being on the line. So just to be safe, I'm going to try like 1, 1. So if I try 1, 1, what that means is I'm replacing the x's with a 1 and a y with the 1. Remember, your test point does not always have to be 0, 0. It can be anything that's not on the graph. So it is good from time to time to test another point just so you remember that. Y is really a 1. Less than, if I take this and I fill in a 1 for x, negative 3 times 1 squared minus 6 times 1 minus 2. This side, what I get is negative 11. So here's my statement. Is 1 less than negative 11? That's false. So wherever 1, 1 is, that order pair, that's the false region. 1, 1 is on the outside. So the outside is false. That means the inside is true. And you guys, that is the intro to section 5.7. I hope you had a great time today. Your assignment is to complete a worksheet where you will be doing exactly what we just practiced here. I hope you're having a great day, and I'll talk to you soon.